Hi everyone and welcome to MathSux. This video is going to help you pass the Algebra Common Core Regents. So we're doing this one question at a time. Here is question 1. Which correlation shows a causal relationship? What we're looking for is when something happens, something else is going to happen, and they're going to be directly related to each other. So if we look at the first answer choice, we have the more minutes an athlete is on the playing field, the more goals he scores. So that's not always true, right? Sometimes a team is winning and then they end up losing later. So that's not it. Choice number 2, the more gasoline that you purchase at the pump, the more you pay. So that makes sense. Yeah, the more you're going to buy, the more you're going to pay. So choice 2 is our answer because this is a direct relationship where if both are increasing, then both are increasing. If you're buying more, you're going to pay more. Question number 2. Given f of x equals 3x minus 5, which statement is true? So we have f of 0. So we're just going to plug in each value for x and see if this makes sense. So f of 0 is going to give us 3 times 0 minus 5, which is just 0 minus 5, which gives us negative 5. So that's not our answer. F of 3 is going to be f of 3 equals 3 times 3 minus 5, which is 9 minus 5, which is 4. So that works out. So choice 2 is our answer here. Question number 3. At Benny's Cafe, a mixed green salad costs $5.75. Additional toppings can be added for $0.75 each. So we start with $5.75 and then add toppings for $0.75 each. So $0.75, let's call this S. Which function could be used to determine the cost C of S in dollars of a salad with S additional toppings? So that's why I used S. So S is toppings, and we know that we're saying this equal to C of S. So now we just need to find this function in our answer choices. 5.75 S, no, so that's not number 1. 0.75 S plus 0.575. So this looks like our answer, choice 2. Question number 4. Which expression is equivalent to x squared plus 5x minus 6? So here we're just going to, if you take a quick look at our answer choices, you can see that we're going to factor this. So I'm just going to use the product sum method where the product is minus 6 and the sum is 5. So we know we're going to have a factor that is positive and negative, which will be plus 6 and minus 1. So we'll get x plus 6 times x minus 1, which is choice 4. You can also check this too. So if you're unsure and these look kind of confusing, you can always also work backwards and check. So you could see by foiling or distributing, you could see that this will give you x squared minus x plus 6x minus 6, and then when you combine like terms, you'll get what we started with. So we know our answer is right, choice 4. Question number 5. Peter has $100 to spend on drinks for his party. Bottles of lemonade cost $2 each, so lemonade equals $2, and juice boxes cost 50 cents each. If x is the number of bottles of lemonade, so let's say this is x, and y is the number of juice boxes, which inequality models this situation? So he has $100 to spend, so that means we're going to want to spend less than or equal to $100, and we're going to be buying lemonade, which we can represent by 2x, and juice, which we can represent by 0.5y. So now all we need to do is find the right inequality, and we can see that it's choice 3. Question number 6. Which domain is most appropriate for a function that represents the number of items f of x placed into a laundry basket each day, x for the month of January? So let's go through each type and see what makes sense. So when you're thinking of laundry basket numbers, you know you're going to be looking for numbers like 1, 2, 3, 4, and just keep counting up. So when you think of integers, that includes these numbers, but it also includes negative numbers like -1, -2. So we're not going to need integers. Rational numbers includes fractions, so you're not going to have like half a shirt or like a quarter of a shirt or anything, because that's what this would include. So not rational numbers. Irrational numbers is pi and radical 2 and all these infinite numbers with no pattern, so that's not going to be a way to describe our laundry. It's going to be choice number 2, which is whole numbers, which is exactly what these are. 1, 2, 3, 4, and it keeps just going up. So it's choice 2. Number 7. What is the solution to 3/2b plus 5 less than 17? So let's just write that over here. And let's just treat this like any other problem. We'll subtract 5 from both sides. This gives us 3/2b on this side, less than, just bringing that less than down, less than 12. And now to get rid of this fraction, we're just going to multiply both sides by the reciprocal of the fraction. So 3/2, we're going to be multiplying it times 2/3 both sides. So it'll cancel out here, and here we'll have b is less than 24 divided by 3, which is just 8, which is choice 1. Question number 8. Which table of values represents an exponential relationship? So let's look at each of these. If we look at this first table here, notice that the x values are going up by 3. So we have 6 plus 3 is 9, 9 plus 3 is 12, and so on. So that means that this first one is a linear relationship, which is not what we're looking for. So let's look at this next one. Maybe this is an exponential relationship. So 2 to 7 is 5. 7 to 12 is also 5. So this is also going to be linear. Let's look at number 3. 4 to 16. So this is 4 squared. 16 to 64. This ends up being 4 cubed. And this is the exponential relationship that we're actually looking for. So choice 3 is our answer. And if this one confuses you down here, just play around with numbers on your calculator, and you'll see that we're actually subtracting by 2.5 here between each value. So this is also linear. Question number 9. Which expression is not equivalent to 5 to the 2x raised to the third power? So just a little side note, 5 to the 2x raised to the third power. Remember, in this case, when there's a parentheses, we're going to multiply the exponents. And when we do that, we'll get 5 to the 6x. So we want to know which one is not equivalent to 5 to the 6x. So we could see with this first one, this is equivalent to 5 to the 6x. So that's not our answer. This is also equivalent to 5 to the 6x. Let's see, this one, choice number 3, is equal to 5 to the 5x. So this one is different and is not equivalent, and that's our answer. Question number 10. Which relation is a function? So when we have a function, we can't have more than one of the same x values. So if you look at this table here, notice we have these 2 1s. So right away, we know that this is not a function. If we look down here at choice 2, you could see that 2 is included twice. So less than or equal to 2 and less than or equal to 2. So we know that this is also not a function. Choice 4, we could see, look at our x values. So just going to underline the x values so you could see them better and see that there's 2 3s. So we know that this is not a function. So by process of elimination, choice 3 is a function. And another way to test if something is a function graphically is to use the vertical line test. So if we drop a line going down vertically and see that our vertical line only hits the function one time, that this is a function. And that's the vertical line test. I also have a whole video on how to tell if something is a function. If you want to check that out, I'll put that up in the right-hand corner and in the description below. Question number 11. The formula ax plus by equals c represents the equation of a line in standard form. Which expression represents y in terms of a, b, c, and x? So they give us this formula here, ax plus by equals c, and we need to put it in terms of y. So here's y. So we're just going to get it alone. So to do that, we're just going to bring ax to the other side by subtracting it. So it cancels out on the left, and we're left with by equals c minus ax. And then to get y alone, we're just going to divide b on both sides. So we're left with y is equal to c minus ax over b. So when we look at our answer choices, c minus ax over b is choice 1. Question number 12. What are the zeros of f of x equals 2x minus 4 times 3x plus 4? So here we're just going to rewrite what they give us and set it equal to 0. And now we're going to kind of take each little mini equation and set it equal to 0. And then solve for x as normal. So here we have x equals 2. So we have one x value. And here we have x equals negative 4/3. So both of these are answers. So we need to find 2 and negative 4/3, which is just choice 1. Question 13. Joe has dimes and nickels in his piggy bank totaling $1.45. This is our total. The number of nickels he has is 5 more than twice the number of dimes, D. So let's say D equals number of dimes. And the number of nickels he has is 5 more than, so 5 plus, twice the number, so 2 times the number of D, dimes. Which equation could be used to find the total number of dimes he has? So if we have total number of dimes is D, and a dime is worth 10 cents, so times 0.1, plus 5 plus the nickels, 5 plus 2D, times the value of nickels, which is 5 cents, 0.05, and the total is going to be equal to $1.45. We get this equation and be able to figure out how many dimes and nickels would add up to $1.45. So now we just need to look for our answer. So we have 0.1 times D plus 0.05 times 2D plus 5. So the order isn't exactly how we have it here, but it's the same thing. So here they just have 0.05 on the other side here, but this ends up being choice 1. Question number 14. Donna and Andrew compared their math final exam scores from grades 8 through grade 12. Their scores are shown below. Which statement about their final exam scores is correct? So then they start having all these answer choices that compare their mean, their median, their range, and their interquartile range. So let's get these all down. So I'm just going to be finding each of these, the mean, the median, the range, and the interquartile range for both Donna and Andrew, and then we can compare them and see which statement is correct. So the mean is always just the average. So here we're just going to add up all the numbers for Donna on our calculator. And then divide by 5, because there's 5 test scores. So the mean here is 91.6, and then the mean for Andrew, let's find that. we get 89.6. So choice number 1, Andrew has a higher mean than Donna. So is that true? No, because we see the mean for Andrew is less than. So 91 is greater than 89. So this is not our answer. So the next answer choice mentions the median. So let's find the median, or the middle value, the middle test score value of each. So that means we're going to have to put each Donna's and Andrew's test scores in order. So first let's look at Donna's test scores. So we want to put them in order from smallest to largest. So we can cross them off as we go. And then to find the median, we're just going to find the middle number. So we can see that the median value here is 92. And now we'll just do the same thing for Andrew's test scores, putting them in order from smallest to largest. And we can see the middle number is 93. So Donna and Andrew have the same median. So no, they are not equal. So this is not our answer. Choice 2 is not our answer. So now, next we need to find the interquartile range, or the IQR. So interquartile range is quartile 3 minus quartile 1. So we're going to need to find both of these quartiles. So the quartiles are just the median of each section of the data. So quartile 1 is going to be the middle number between here and here. So to find the middle number of this half of the data, we're just going to add the data, 87 plus 90. It's like you find the average, the middle number, and then divide by 2. So quartile 1 over here is 88.5. Quartile 2 is always the median. And then quartile 3 is going to be the median of the last half, which we could just see is going to be 94.5. So to find the interquartile range, we're going to do Q3, which is 94.5, minus Q1, which is 88.5. Which is 6. So now let's find the interquartile range over here. So here is quarter 1, which will be, let's find the midpoint, 78 plus 87 divided by 2, which is 82.5. Here's quartile 2. And then we could see quartile 3 is just going to be 95, because that's the middle number between 94 and 96. So now to find the interquartile range, we'll do quarter 3, 95, minus quartile 1, 82.5, and let's plug that in and see what we get. 12.5. So now we need to compare these numbers, 6 to 12.5. Andrew has a larger interquartile range than Donna. So yes, he does. This is it. This is the answer. Choice number 3. So I went kind of fast here going over the different quartiles, mean, median, and interquartile range. But I have a video on box plots and how to find that. Super easy. So please, with a bunch of examples, so please check that video out right here. On to question 15. The first term in a sequence is 5, and so the a sub 1, and the fifth term is 17. What is the common difference? So when we have the common difference, we know we're going to be working with an arithmetic sequence. So the formula for that is a sub n is equal to a sub 1 plus n minus 1 times d, where a sub 1 is the first term, n is the term number, d is the common difference, which is what we're trying to find, and then a sub n is the value in sequence. So we have almost all this information except for the common difference, right? So to plug this in, so the value in the sequence, they give us 17 is the fifth term. So that's the example we're going to use. So the first term happens to be 5 plus n minus 1. So we have two 5s. So this is equal to n, 5, minus 1 times d, the common difference, which we don't know yet. So now I'm just going to use regular algebra to solve for this. And you can see that we're going to get d is equal to 3. Choice 3. I also have a bunch of videos and practice questions on arithmetic sequences and geometric sequences, so please check that out. Question 16. A quadratic function and a linear function are graphed on the same set of axes. Which statement is not possible? So let's go through each one. So choice number 1, the graphs do not intersect. So we have our coordinate plane, and we have a parabola can be going this way, and we can have a line at the same time just going straight across. Then they could possibly never intersect ever, so that's not our answer. Choice number 2, the graphs intersect at one point. So let's see if that's possible. So that can happen. If the line is tangent at one point to the parabola, that can happen, so that's not the answer. Choice number 3, the graphs intersect at 2 points. So if we have our parabola and then our line goes through it twice, that can also happen. So that's not our answer. So by process of elimination, choice 4 is our answer, because it is not possible for one line to intersect a parabola at 3 points. So that's not possible. Question 17. The expression n minus 3 squared is equivalent to what? So we have n minus 3 times n minus 3, and now we're just going to multiply everything. So there's different methods of multiplying. I'm going to be using the FOIL method, otherwise known as distributing, where we do m times n, which gives us m squared, and then we distribute to the other term here. M times minus 3 is minus 3m, and then we're going to do this term, minus 3m times m, minus 3m again, and then minus 3 times minus 3, which gives us plus 9. And when we combine like terms, we'll just get m squared minus 6m plus 9, which is choice 3. Question 18. Mrs. Rosanna asked her students to explain why 3, negative 4 is a solution to 2y plus 3x equals 1. 3 student responses are given below. So we have Andrea, she says, when the equation is graphed on a calculator, the point can be found within its table. So that sounds right. Let's check it out. So first, I'm going to want to reorder this into y equals mx plus b form, so I can plug it into the calculator easy. So we're just going to set this equation and get y alone. So when we do that, we'll get negative 3/2 x plus 1/2, or 0.5. So I just converted this to 0.5. So let's just plug this into our calculator. And then when we go to the table, we could see that 3, negative 4 is on the table. So Andrea is right. So we know that she's correct. So let's look at what Bill says. He says substituting x equals 3 and y equals negative 4 into the equation makes it true. So that would also be true if you could test that out, or you could just realize if it's on the table, that's always going to be true. So Bill is also correct. And Christine says the graph of the line passes through the point 3, negative 4. So the same thing. This is just another way of saying the same thing that Bill is saying and Andrea is saying. When you graph this, we know that it's on the table of values, therefore it's going to be on the graph here also. So all 3 are correct. So this is choice 4. Question 19. 4 quadratic functions are shown below. Which statement is true? So it looks like they're looking for the maximum, so it starts comparing the maximum of f of x, maximum of j of x. So let's find the maximum of each function here. So just looking at this, we can see that the highest y value is 5. So here we have the max is 5. Over here, this is just graph for us already, so we could see that the max value, so the max value here is 4. And I just got that by counting up 1, 2, 3, 4. So we're looking for that y value, that max y value. And then for g of x down here, we could just use our calculators again to find the max value. So I'm gonna plug this in, negative x minus 4, and let's see what we get. So we can't tell them what the max is, but we see that the max is right here. So to find the max, we're just gonna go second calc, go to maximum, press enter on the left, and then swivel to the right, press enter again, and we could see that y is equal to 5. So the max is equal to 5 here. So let's find the max of j of x, our last function. So we have negative 0.5 squared plus x plus 4. See what that looks like. So our max value is going to be somewhere around here. And you can see our max is going to be 4.5. So now we could look at each answer choice and see which is the answer. So the maximum of f of x, which is 5, is less than j of x. So that's not correct. The maximum of g of x, which is 5, let me just cross that out, 5, is less than the max of h of x. Here's h of x, and the max is 4. Also not correct. F of x is equal to the max of g of x. So that looks right. Both are 5, right? So we got one. So choice 3 is our answer. Question 20. An example of a 6-degree polynomial with a leading coefficient of 7 and a constant term of 4 is. So when we see 6-degree polynomial, that means we're going to have a variable that, so let's say x, raised to the 6th power with a leading coefficient, so with a whole number being multiplied by this, of 7, and a constant term, so just a constant term with no variable, of 4, so plus 4. So we're going to be looking for something in here that has 7x to the 6th power plus 4. And if you look around, you can notice that only choice 2 has that. We have 7x to the 6 over here and a 4 here. So choice 2 is our answer. Question 21. This one's a little weird, but okay, let's take a look. In the equation, a equals p times 1 plus or minus r raised to the t. A is the total amount, p is the principal amount, r is the annual interest rate, and t is the time in years. Which statement correctly relates information regarding the annual interest rate for each given equation? So we're going to be focusing on this part, 1 plus or minus r. And they're going to be giving us information. We're going to be checking to see if it's correct. So for a, p times 1.025 raised to the t, the principal amount of money is increasing at a rate of 25% interest rate. So that would mean 1 plus 25% interest rate. So they're saying that the r here is 25%, or 0.25. So that means 1 plus 0.25 would have to give you this, 1.025. But 1 plus 0.25 gives you 1.25, right? So these are not equal. Does not equal 1.025, what they gave us. So that means that this is not our answer. That's how we're going to be checking, filling in for the interest rate and seeing if it equals what they said. So let's try the next one. 1 plus the interest rate they give us is increasing at 0.52, so 0.52. So this is going to be equal to 1.52. Does that equal what they gave us? No, that does not equal 1.0052, so that's not our answer. For 3, so this time the principal amount of money is decreasing at a 14% interest rate. So this time we're going to be subtracting. So before they were increasing, so we were adding 1 plus r, but see the formula has 1 plus or minus r. So since it's decreasing, we're going to be doing 1 minus the interest rate they give us, which is 14% or 0.14, which just gives us 0.86. So does that equal, we need to ask ourselves, does that equal 0.86? And it does. So that's our answer. So that's the only one that's correct. Choice number 3. Question 22. It takes Tim 4.5 hours to run 50 kilometers. Which expression will allow him to change this rate to minutes per mile? So when we're converting, you always want to cancel out the old units and be sure you're left with the new units. So the new units, we want to be left with our minutes per mile. So if we can cancel out hours and hours, kilometers and kilometers, notice that we're left with choice number 1 right away. We got our answer, minutes per mile. So choice 1 is our answer. And if you try to do this with the other examples, you won't be able to. So just for example, you can cancel out kilometers, but then notice you can't cancel out hours. So that's our answer. Question 23. When the equation x minus 1 over 2 minus a over 4 equals 3a over 4 is solved for x in terms of a, the solution is, so we're going to be solving for x in terms of a. So let's write out the equation on the side here. So I want to get x alone. So the first thing I'm going to want to do is bring this a over 4 to the other side. These cancel out. And then we're left with 3 over 4 plus a over 4. So I'm just going to bring this up here. And notice now these have the same denominator, so we can actually combine like terms. 3a plus a is 4a over 4. And then the 4's can cancel out, which just gives us a. But we still want to get this x alone, so we're going to first multiply both sides by 2 to get rid of this 2 in the denominator. So we get x minus 1 equals 2a. This isn't a square. This is just a times 2. And then to get x alone, last step, just adding that 1 to the other side. So we get x is equal to 2a plus 1, which is choice 4. And last but not least, here we have question 24. If a sequence is defined by recursively as a sub 1 equals negative 3 and a sub n equals negative 3, a sub n minus 1 minus 2, then a sub 4 is. So I just mentioned what all this is in math terms, but if we, let's spell out what each of these means. So they give us a sub 1, which is negative 3, which is our first term. This is a recursive formula. So they'll always give you the first term and then this other formula to find the rest of the terms, a sub n minus 3. So what we have to do is plug in. So we want, and our goal is to find the fourth term. So this is our first term. We're going to find the second term. And to find the second term, we have to go in order like this in order to get to the fourth term. So in order to find the second term, we're just going to use this formula, negative 3. And then for this a sub n minus 1, we're just going to plug in the previous term, which is negative 3, which is the term they gave us. Negative 3 times negative 3 is 9, minus 2 is 7. So our second term is 7. So now let's try finding our third term. So we're just going to use the same formula, negative 3. And now instead of plugging in negative minus 3, we're plugging in the previous term value, which was 7. So we get negative 3 times 7 is minus 21, and then minus 2, which will just give us minus 23. And now to find the fourth term, which is what they wanted us to find in the first place, using the same formula, plugging in the value of the previous term, which is minus 23, And let's see what we get. Minus 23 times gives us 69 minus 2, which gives us 67. And notice we have that answer choice for choice 4, 67. So that's our answer. So this is the end of part 1. Look out for part 2 coming out soon. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!